Hi, welcome back to Science 1206, the motion unit. I'm Ms. Ledwell, and in this video, we'll discuss how to analyze position time graphs. Let's get started. On a position time graph, steep lines indicate faster movement, higher velocities, when compared to lines with a more gentle slope. Lines with shallower slopes indicate slower movement. On the position time graph below, which line indicates an object traveling at the fastest speed? It would be the blue line. That's because this line has the steepest slope of the three lines on the graph. The direction of the slope can also indicate the direction of motion, with positive slope showing motion in the positive direction, forward, like on this graph, and negative slopes indicating motion in the opposite direction, backward, like on this position time graph. Let's look at some examples. Describe the motion in the position time graph below. So we have three different things going on in this graph, something from 0 to 3 seconds, from 3 to 7, and then from 7 to 8. Let's begin with 0 to 3 seconds. In this section of the graph, we see an object moving forward from the reference point of 0 with a constant velocity because we have a straight sloped line. When we calculate the velocity using our slope, rise over run, the velocity is positive 0.5 meters per second, or as indicated on the y-axis with position, it's moving 0.5 meters per second to the right. In the next section of the graph, we see a straight horizontal line. Straight horizontal lines on position time graphs indicate that the object is not moving. If we look at the graph at 3 seconds, 4 seconds, 5 seconds, 6 seconds, and 7 seconds, in all those spots, we can see that the position hasn't changed. It's 1.5 meters right. That means the object has not moved. In our last section of the graph, the object is moving backward past the reference line with a constant velocity of negative 5 meters per second, or the direction would be 5 meters per second to the left. Let's look at some more examples. What is the position of the object in this position time graph initially? The initial position of the object is 0.0 meters. What is the position of the object after 4 seconds has passed? So the position of the object after 4 seconds is 1.5 meters right. You can draw a line up if you want. Draw a line up from 4 seconds, touch off your graph, and then continue the line straight across to your y-axis, and you can see the position is 1.5 meters right at a time of 4 seconds. Our next question is, what is the velocity of the object in the first 3 seconds of motion? To determine velocity from a position time graph, you need to calculate the slope. So we find the point on the graph of 3 seconds, because it asked us in the first 3 seconds, and we make a triangle, and then we calculate our slope, which is rise over run. So we have 1.5 meters right minus 0 meters is our rise, divided by our run is 3 seconds minus 0 seconds. So when we calculate that, we get 0.5 meters per second to the right is our velocity. Our next question asks us to figure out the velocity at a time of 6 seconds. At a time of 6 seconds, the object isn't moving, so the velocity is 0. So far, we've looked at straight lines on position time graph, but position time graphs can also have curved lines. Curved lines on a position time graph indicate changing velocity, meaning the object is speeding up or slowing down. This indicates non-uniform motion, in which the velocity is not constant. Now it's time for you to do some practice. Pause this instructional video and grab a pencil and some paper, or open up a blank document on your electronic device. If you have access to a pencil and some paper, you're going to be drawing some graphs, so this would be the best format to use. Number your paper or document from 1 to 3. You'll need to leave space between each number. As each problem in the tables on the next slides is revealed, write down your answer. We will then review the correct answers one by one. After numbering your paper or document, please resume this instructional video. So what you're going to do is sketch a graph. You do not need to put units on the axes because we're just sketching what the graph would look like. We're not plotting data points. So here's the description. It says a puppy is running to the right of a park bench at a constant speed. Sketch a position time graph showing this movement. And remember, you're not graphing data, so you don't need to include a scale or units here. Your graph should look something like this, with a sloped straight line because it's a constant speed indicating uniform motion. Our next description says Buddy is sleeping soundly under a shady tree. Throughout the afternoon, Buddy stays in the same spot, enjoying his nap. Sketch a position time graph representing Buddy's position under the tree. And your graph should look something like this. So I'll direct your attention to the black line across the x-axis. Buddy hasn't moved from his position underneath the tree, so it's a straight line all along the x-axis. In our last one, Charlie starts at the garden gate and walks backwards at a steady pace. Sketch a position time graph to represent Charlie's backward movement away from the gate. Your graph should look something like this one. So starting at the reference point, we're moving away from the origin in the backward direction down below the x-axis. Now it's time to review. Complete the learning activities you'll find in Brightspace.